Hi guys, welcome back. Appreciate you joining. So, first and foremost, I only had about 2 hours sleep. So, if I'm a bit lethargic and I look knackered, it's because I am knackered. But if I sleep now, it's gonna be problems. So, this is episode 2 of the devlog of my game. To quickly recap what I did last episode, we what I done was added the alert for the when returning to the ready state when it's not a strike. Added lerp for a smooth animation transition of the paddle. And also what we did was we implemented something called TryStrikeBall. So transitioned from I transitioned from a collision-based mechanic of striking the ball to something more akin to hit scan. And with that, I've implement I implemented TryStrikeBall, which is a method which is essentially pulling in the data of where the ball is, where the pivot is, figuring out the distance, figuring out the angle, and if it's within the distance and angle, then it will return true, it will be considered a strike. And if not, this method would return false. So for today, well, I don't know how much I'm gonna actually get done today, but for now, the next two things I want to do is with the paddle, the whole paddle instance, I want to try to implement a sort of visual circle around it, just so that oh, there's a fly, just so that visually, in terms of debugging stuff and figuring out stuff within the inspector, I'd be able to see like what the max radius is, because right now I can't really tell. So I want to try to implement that. Then what I'm going to try to do Then what I'm going to try to do is with set up try strike ball, then I need to actually implement that within my, where have I put it? Within my winding state when I call try strike ball, figure out what to actually do with it and how I'm actually going to manipulate the ball. So those are the next two steps, and I'm going to get on with trying to do that. Alright, so my first task I've added a debug circle, and I've also managed to add a wedge as well. So you can see a nice little wedge, and it rotates. It lets me know the radius and the angle that I'm aiming. And as you can see, like the paddle that I've put in there is not actually indicative of what's actually happening inside the code. How I've implemented that. So we've got a method called draw. This is to draw stuff on the canvas. I added a little export field called show debug draw because since this is supposed to be used as a debug sort of tool, got it here. And I just wanted something inside the inspector so that I could toggle it off, because it's just a debug tool at the end of the day, so I don't want it always to be on. So we've got that And inside draw, we're checking, is it toggled on or off? If it's toggled off, then just return. Don't redraw this. Else, if it's show debug draw is turned on, then we want to draw the max radius circle, and you do it like this. You call draw arc, and what draw arc is, you take the center, the radius, so the center is dot 0 since it's attached to the paddle node 2D object. The center is just at 0, so you put the start at 0, the max at max radius 0f. What is that? Oh, start angle. So start at 0, max angle full 360. 64 is how, because it's how it works internally. It's just drawing. Why is that not working now? Oh, I turned it off here. That's why. Okay. How the circle works is just a bunch of straight lines to make up, like a lot of small straight lines to make up the circle. So that's what 64 is doing. It's dictating how sharp you actually want it. The higher the number, the better. And the new color, whatever color you want, 2F is the thickness. And then I decided to implement the strike wedge. You got the half wedge, obviously, because if the angle is 90, you want 45 on the right and 45 on the left so that it's centered. The facing angle taken straight from my TryStrikeBall. There you go. Where you just take the pivot rotator rotation and take away pi divided by 2. So that's how we get the facing angle. Start angle, you just take the facing angle and minus the half wedge, so you get the left half. And in the end angle, you just add the half wedge to the facing angle. And then that's when we draw first edge here. You draw that line for the first wedge, draw that line for the second wedge, and then the arc for the top bit. And that's all been implemented. So now it's much more accurate and much easier to tell when we use our debug. So here, if you strike, boom, it shows strike at the bottom. So this shouldn't be a strike since it's outside, and it's not a strike. This shouldn't be a strike because I'm testing if the center of the ball is within the circle. And yeah, not a strike. And then you get little things like this. So this won't be a strike because it's not within the wedge, but this should be a strike because it's within the edge. There we go. So yeah, that's great. That's working. That was quicker than I thought. Alright, so with that done, that little detour, now I'm going to try to figure out what to do with my striking. We've got TryStrikeBall sorted. As far as I'm aware, that's basically done. And we're calling TryStrikeBall within the winding state of my handle strike method over here. So if it's a strike, if TryStrikeBall returns true, then it's a strike. If it doesn't return true, then it's false. So I'm going to figure out how to, if it is a strike, how to transition that into movement of the ball and manipulate things like that. So I'm going to try to figure that out. Yes, so been doing a bunch of changes. What did I say that I was gonna do? Oh yeah, sort out the strike. Right, so what I did to sort out the strike. Let's go up here actually. What's the best way to explain this? Alright, so what I did was I implemented an export field called base strike force. So this would be the velocity that I want the ball to travel if a strike has been detected. So we have that. And in terms of dealing with the strike, I've gone into where I had my print statements to detect whether it is a strike or not. So TryStrikeBall, if it returns true, that means the ball's within range and within the cone. So I've added another method called apply strike to ball. That's where I'm calculating everything. So let's scroll down to apply strike ball method. Let's see if my controller still works. Yeah, it does. So we've got apply strike ball right underneath try strike ball. That's a mouthful. So what we're doing is we're getting the vector between the pivot to ball. That gives us the direction of where we're aiming. We've got ball global position minus pivot rotator global position. That gives us the vector, basically the direction of the ball to the pivot. And since it's the pivot rotator, is going to continuously what do you call it? It's going to track in terms of which direction we're actually pointing in. And then what we do is make a variable called strike direction, and we take pivot to ball and we normalize it. The reason why we normalize it, what normalizing does is it takes a vector, a direction vector like pivot to ball, which lets us know the direction, and it sets the length. It sets the length to 1, and the reason why is when we set the velocity of the ball, we only want to apply base strike force. Now, let's say that the distance was I didn't normalize it, and the distance was, I don't know, whatever. It would take that distance and multiply it with base strike force. That meant depending on where the ball hit, I might get crazy ball speeds because I'm multiplying what have I set base strike force to. I'm multiplying 800 with the direction and length and whatnot. So what we wanted was to normalize it so that the length was 1, and it didn't matter no matter what. As long as I strike the ball, it's going to strike at the same speed. Now later on, what I want to do, I do want to play around with different speeds of ball, like essentially what I want to do. This is down the line. We've got here. There we go. That's the wedge. If I if I strike the ball and the ball's here, I want to apply, let's say this will be 800 speed. However, if I strike the ball and the ball's here, I want to be able to change that to, I don't know, let's say 2000, whatever speed. So I do want the velocity of the ball when striking to be variable depending on how close you are, but I want it to be measured and controlled. I don't want it to be chaotic. So I'm going to try to implement that at some point. However, for now, all I've done is normalize pivot to ball. So we've got the direction, and we multiply that with the force that I want to apply on the ball, and then set the linear velocity of the ball to that. Oh, and how that works out, let's do this. Has anything changed? No. Okay, so how that works out, let's build this. Is my controller connected? Yeah. If we play the game, boom, strike, boom. Oh, it's actually more difficult. There we go. And I can set a direction and it goes. So I'm going to play around with the speed as well because I'm not a big fan of how slow it is. But you can see it working. Let's try that again. Strike, strike, strike. Oh, unfortunately, we can't see the bottom. But the bottom said strike. And now it says not strike. So if I go, obviously the ball's not in play, so it's not going to be strike. I also did have a I ran into an issue. I'll try to explain this. So we've got all that. Let's clear that out. So we had the pivot rotator and we had the max radius. That is max radius mister. And we got the pivot rotator. So we got that. However, the ball is a rigid body 2D and it has a collision shape. Now I know they do something with the physics. They do different things. But it's important to have that so that I can detect collisions with stuff like the wall and the ceiling. So that's fine. However, on the paddle, I've got paddle body, which is this thing here. Now originally, paddle body was... What was it before? Yeah, so the paddle body was an animatable body 2D. And I also had a collision shape. Yeah, so I had a collision shape 2D there as well. Now, what it was doing, so since I've got this paddle body as just a visual for me to realize how much I've winded up, it's a visual for me to know like if I'm winding or if I'm not, and I'm going to make it more seamless and better looking in the final game, obviously. But right now I've got that. What is it called again? Paddle body. We've got an element here. Let's make that red. We've got an element here called paddle body. Now this had the collision stuff on it. It was an animatable body 2D and had that collision stuff. So the problem was that even though, since the ball has physics as well, even though it was phasing through and the ball would reach here, if I decided to wind and strike, the ball would move upwards, the paddle body would move upwards faster, and essentially the ball would hit the bottom of the paddle body and fall down. Obviously an unwanted bug. I wanted the ball to have physics so that I can sort out the physics between the wall and the ceiling. But I don't want that to have any physics because I'm calculating all this through hit scan. So what I've done, I removed the collision shape 2D from the paddle body and I changed paddle body to a no 2D. That way there's no collision. That way there is no collisions happening with that. So maybe I can so now it doesn't react to the bottom of the paddle, it just, if it's detected, boom, keeps going. It's kind of fun. Alright, so that's done. That was more difficult than I thought. So next, what we want to try to implement. Let's see. Next, what I'm thinking, what I should implement. I want to try to implement that aspect that I said before of if the ball is lower, make it a faster velocity, and if the ball is further, make it a slower velocity. Try to implement that. I also am going to play around with the velocity speed, the base speed. Up here. Because I think that's a little bit too slow. It seems like it's not pushing up against gravity enough. So either I need to change this, play around with this, or what I do is I play around with the gravity value to try and make gravity lighter, or the mass of the there's multiple ways to do this. I don't know which one. So I'm gonna have to play around with that. Alhamdulillah, sorry. And then obviously manipulate the strike back speed depending on how close the ball is. And one other thing, a little small thing. Hopefully I can show it here. And it's hard to replicate, but okay, firstly, that's going straight up. Okay, so that's another thing. Let me see what that is. Oh, this is going to be difficult. So that's going straight up. What if I, okay. Alright, so I've just noticed a new bug. A couple of things. Okay, this is much more complicated than I thought. So, a couple of things. Other than what I already spoke about. Let's turn that off. Is on spawn. So if I don't move it left and right on spawn, direction is cancelled. Let's do a text. Direction is cancelled is not responding on spawn only once X paddle X value changes. So we got this problem. So I need to figure out why it's doing that. Not sure. The other problem I'm having is sometimes direction isn't being taken into account. Now I know what is actually happening for this one. So what's happening is, let's say we got the pivot rotator. Let's say I'm aiming here, and it's, let's say we start off here. Right, oh, wonky. We aim this direction, and the ball is here. What it's deciding to do is take that angle instead of going the actual direction. Let's try that again. Sorry. So what happens? Ah, see. Because even if I'm like that, let's say I hold it like that, right? The ball sometimes will go here. So let's say it's coming down and it will go here. It will instantly go that direction. Even though it feels like it should go this direction, since it's so close to the center that it's very sensitive. So what I want to do, I hope that makes sense, but I do understand in my mind what's going on. It's so close to the center, it's over here. We're aiming this direction. We obviously want the ball to go there, but because it's essentially so sensitive, it takes that direction up there and it goes the other way. Let's see if I can replicate again. See that? So like, it's really just going. So a couple things I could do. Either, let's make it either add a type of momentum or the closer to the center, the more direction, the more aim matters. So there's two ways I can go about that. So the two solutions that I'm thinking of is if it's coming out down fast, if the ball's coming down fast like here, it shouldn't just directly go like that. It should more, if it's coming down here and I'm aiming that direction, it gets hit, then take into account the momentum and then kind of almost arc, but take into account momentum. So I could do that. That could be a solution. Or another solution that I'm thinking of, the closer to the center it is, the more that it should align with the direction rather than align with this straight line that I'm calculating. So we got that. The last thing that I realized is, okay, and the last thing I realized what's happening is we've got the pivot rotator, boom, boom, is edge cases. Now I think, here's the thing, it's probably being accurate. So since the ball's coming down at speed and I strike it, and the ball might be like here, obviously it's center ball there, but it's coming down so fast, and generally, oh, something on my face, generally it seems like on the screen it should hit, but because it's going so fast and it's just off of the strike area, the ball just phases through. So what I'm thinking of to also add beyond this is to add some type of forgiveness, where if the ball is traveling really fast and it's close enough, have some sort of buffer area where if it's within, like, I don't know, let's say 10 pixels, whatever the value might be, if it's within that during strike, that it would count. The idea, so I got that idea from, there's a game called Celeste, and in Celeste, how it works, what I didn't realize how it works is, Celeste is a platforming game and it's really fast paced. Let's say you got a platform and your character's running, and let's say your character's here, right? It's off of the ledge, but however, you can still hop off at this point. So it actually gives, even though the game felt really hard, but it was really great gameplay, it gave this much forgiveness when you decided to jump off of a platform. So adding forgiveness might actually feel better. So I might do that. So for what I'm going to do is I'm going to take a little bit of a break because I'm tired. I'm going to try come back to this after a little break, have some water, and then what I'm going to try to do is figure out the spawn problem where direction isn't being applied on spawn if I don't change the x value. So I need to sort that bug out. Then I need to figure out a way to solve the puzzle of what do I do for when the ball is really close. Do I sort it out with momentum, or should I sort it out by calculating the distance, and if it's close enough, then the more aligned towards the aim it should be. So once that's done, then figure out the edge case scenario where if the user strikes and the ball is close enough, then allow that ball to be hit. So I'm going to take a little bit of a break and I'm going to come back and start coding this. Alright, so I realized one thing. So I was developing, was figuring stuff out and trying to find a solution to what I was speaking about before, and realized that aim actually isn't being taken into account. The way it was working before is we have pivot rotator. How many times I want to do it? Let's say I've got this angle here, right? That is a shoddy. There you go, that's better. And the ball comes directly here, so this is directly above, and the ball's here, right? Now, if I shoot, even though the middle of the wedge is over here, if I shoot, all it's determining is the ball's position in comparison to the pivot rotator. So therefore, no matter where I aim, if it's directly above the pivot rotator, it will always shoot upwards. Now that's not how I wanted the game to be, and that's why I was having that issue on load, where the ball is directly on top of the pivot rotator, and even though I was aiming, because I hadn't moved the pivot rotator, it was always shooting up, basically. Sorry, I'm so tired. I'm knackered. Didn't have any sleep. So that's what was causing it. It wasn't taking into account the aim of this. No matter if I turn the aim here or turn the aim there, it would always shoot upwards or shoot in the direction of where the pivot rotator was. So let's say if the ball is here, this difference here is what's this sort of vector unit. So how I fix that, so there's two solutions. I wanted to take into account both this direction and the direction of aim and blend them together. I might try that tomorrow, but I thought what's easier for now is just to take the raw aim. So take that aim and just apply it to the ball. And that's what I'm doing here. Right here, paddle facing angle, which we used before for when we try to strike the ball. Just take that, grab the strike direction by creating a vector unit, and create that using cos and sine. I'm not going to pretend to know the maths on this. I don't really know the maths, but I know it works. You apply the paddle facing angle, that's the x coordinate, and this is the y coordinate. And then you leave the ball linear velocity the same. And how that changes the game, you're gonna see. So let's build this. Is my controller working? Yes, it is. So we got the game. That should go straight up, but if I angle it, boom. There you go. Angle it right, angle it left from here, right. It's always taken into account the aim. So that's what I've done. That took a lot out of me. I've had 2 hours sleep. Feel like I've done a lot today. So let's quickly recap what we've done, and we can end this video. So what we've done today as a recap. Firstly, why do I say we? I did it. Don't know why I do that. Anyways, what we did was we added the circle to showcase the max radius and a wedge to showcase the strike area. And we did this through code over here. Where is it? It's the draw method. The draw method does it all, and you have to in physics process you have to call Q redraw in order to constantly redraw it every frame. We've done that. What we've also done is change the paddle scene, so we got rid of any collision elements or reactive elements that interact with the physics engine of the game engine. I kept it on the ball because the ball is going to react with stuff like the wall and stuff inside the scene, which I might add later, but for the paddle it's not necessary. So we've changed, at its core what the paddle is. Done that, and then finally what we've done is not finally, sorry, we also incorporated apply strike to ball. At first applying the strike in terms of its direction in comparison to the pivot rotator, and obviously we've transitioned that into the direction of where it's aiming. So that's what we've done today. I'm done for today. For tomorrow or the next episode, what I'm going to try to do is to try to incorporate a blend instead of being purely directional of the angle, and instead of where it's located compared to the pivot rotator, try to blend the two with maths and see how that feels. I'll just fill that out. If it feels good, I'll keep it. And if it doesn't feel good, I'll stick with the angle of the rotator. And then beyond that, we'll figure it out. So thank you for watching. I appreciate it. See you later.